See how much polluted our environment right now. It is not good for me who have an asthma disease. This happened due to the air pollution caused by the fossil fuel energy, which release the carbon dioxide into the atmosphere. Before I'm started, greetings and Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faiq bin Ahmad alias Sapli, and my number matrix is 17181056/1. There are many research and work that had been developed to find an alternative energy to replace the fossil fuel energy. One of the alternative energy is nuclear energy. Nuclear energy had been evolved year by year to replace the fossil fuel energy. However, there are some problems that we need to face in order to use it as the main energy. Firstly, nuclear waste. It will produce the plutonium actinide, which it is an hazardous material in the world. Secondly, we need to sustain the energy, which we can use it in a long period. Third, it can be used as a weapon. What happened in the Fukushima and Nagasaki? Bomb atom, right? So, in this video, I will tell everything about nuclear energy and about my project. Okay, now I will tell you about my final year project, which entitled as the research on the effect of burnable absorber with thorium-232 in small modular reactor fuel matrix. In this venture, I will use two types of fuel arrangement, which is uranium-thorium fuel assembly and uranium fuel assembly only. To investigate the effect or the impact of burnable absorber, I will use different weight percent of burnable absorber, which is 0%, 3.6%, 5.0%, 7.8%, and 12%. The calculation and the simulation that was used in this venture is MCNPX integrated with Cinder 90 for the burn up calculation. Why I'm using thorium-232 instead of using uranium-235? Simple, because thorium-232 will not produce plutonium isotopes. Then, why I'm combine uranium with thorium? Because thorium is a fertile nuclide, which it cannot directly undergo fission reaction. Then, uranium is a fissile nuclide, thus it can directly undergo fission reaction. Thus, it will increase the energy that will be produced in the reactor. Next, why I'm choose gadolinium as the burnable absorber? Because the effect of gadolinium is more shorter rather than any burnable absorber in the world. Furthermore, in this venture, the analysis was divided into three parts, which is initial K infinite, fuel utilization, and in-cycle neutronic analysis. Firstly, initial K infinite analysis was based on the event where the fuel is on steady state, where there are no fission reaction in the reactor. As expected, the amount with 0 weight percent of gadolinium have the highest initial K infinite for both type of fuel assembly. Hence, this proof that gadolinium it can decrease the neutron multiplication factor in the reactor. Then, why uranium thorium have higher initial K infinite rather than uranium fuel assembly? It is because thorium have larger thermal absorption rather than uranium. So, this is good for the reactor as we can lower the neutron multiplication factor by using gadolinium. Next, in-cycle neutronic analysis was based on the event where the fuel start to burn up. As you can see the graph, the K infinite or neutron multiplication factor decrease with increasing weight percent of gadolinium for both fuel assembly, which uranium thorium have higher K infinite rather than uranium fuel assembly. Hence, we can see that the presence of gadolinium will affect the K infinite by absorbing and capturing the thermal neutron in the reactor. Then, as you can observe, the graph for uranium thorium is a bit slopey, which the effect of gadolinium is long lasted in this type of fuel assembly, which this is not good for economical purpose because of the slopey trend. This can be improved by putting this fuel arrangement in longer type of reactor, and it will be good for the economical purpose. Finally, fuel utilization analysis was done to find the amount of fuel that have been produced and used in this reactor. The presence of gadolinium influenced the utilizing of uranium-235 for both fuel assembly, where it is decreased with increasing weight percent gadolinium. This happened due to the characteristic of gadolinium that shielded the uranium-235 to undergo fission reaction, where this influenced the production of plutonium-239. As you can see, the amount of plutonium-239 that produced is also decreased with increasing weight percent of gadolinium, where uranium-thorium have lower plutonium-239 production rather than uranium fuel assembly. Hence, it is justified that the using of thorium with gadolinium will decrease the amount of plutonium-239 that will be produced. In a nutshell, nuclear industry need to be improved in order to replace the fossil fuel energy because of its own benefit. Then, for the future works, I suggest that we can use the same fuel arrangement in this venture in a bigger type of reactor, which we can see the impact of burnable absorber, are it the same or not in bigger reactor or small modular reactor. Thank you.